Hello students, we are studying the chapter force and pressure and today we are going to study pressure. Okay. So in class 7, you all have studied about the storms and the cyclones, okay? And we have seen that yes, why does this occur? Because there is a difference in the pressure. Okay. So what is this pressure? Okay. What is the relation between this force and the pressure? We'll be understanding with number of examples. Okay. Suppose you are taking a nail. कैसा होता है nail बेटा? This type, isn't it? This is what? A nail. So yes, in the nail, what do you see? That here it is totally pointed. Okay, you go on hammering. Okay, on the wall through this pointed nail. Okay, suppose if it is not pointed. Okay, if it is in this form, okay, this two, okay, you take this two and yes, try to hammer it on the wall. Which one will be hammered or fixed on the wall first? This one, isn't it? Why does this happen? Here, the area you see which is in contact with the wall is too small. Here, it is more, isn't it? So, when we are hammering this nail, we are applying force to it, isn't it? And accordingly, the nail is being just fixed on the wall. So, as you have seen by practically doing the experiment, that yes, this nail gets fixes in the wall. This, it is very, very difficult. This is because the pressure over here is more and the pressure over here is less. So what is this pressure? Pressure is the force per unit area. Pressure is force per unit area. It means force upon the area on which it is acting. Okay, so this is the reason. Here the pressure is more and the pressure is less over here, because when we divide, we are applying force, okay, and the area is small over here. So what will happen? We are saying that this pressure is inversely proportional to the area on which the force is acting. Here, the area is less, so the pressure will be more. Here, the area is more, so pressure will be less. So, if the pressure is more, it will be fixed very fastly and easily on the wall. This is why the pointed nail, okay, fixes earlier or easily in the wall rather than the unpointed one. This you can see with the knife also. Okay, suppose if the knife is too sharp and you want to cut anything, you can cut it easily. But if the knife is not sharp, what happens? You go on cutting it, okay, applying force to it. But yes, the result is then also unsatisfactory, isn't it? That is why, because the sharp knife, okay, here we are seeing that the pressure is more, and as the result to cut the vegetables or anything, it becomes easy, because on the sharp area, what happens? If the sharp edge is there the force will be acting upon that area only, and as the result, the pressure will be more. But if the area is more, if it is a blunt knife, it is not sharp, okay, what will happen? The pressure becomes less. As well as the result, you are not able to cut the vegetables or anything whichever thing you want to cut it. So here we are seeing about the force which is acting perpendicular to the pressure which is being computed or exerted, and this is known as what? Thrust. Okay. So some more examples, let us see. Suppose a person, okay, just carrying bags on his head, okay, and if he keeps those things as it is on the head, what will happen? Too much pressure he will be feeling, okay, and it will be too heavy for him to carry also. But if he takes his turban, just roll it off and keep it on his head, and then he keeps the things like you see the coolies do, okay, what happens? Now what? How they are able to carry it easily? Because as he has taken the turban, okay, rounded it, okay, it has increased the surface area. And when the surface area is increased, now what will happen? The pressure will be decreased, and this person will not feel that much pressure if he would have kept without the turban. With the turban, the pressure is less as the surface area has been increased and he can carry the bags easily. That happens with the strap of the school bags also. You all have your school bags, isn't it, beta? Okay? But what do you see? Are the straps, okay, of the school bag thin or is it wider in nature? Okay, you'll be seeing it is wider in nature. Okay, वो दुबला पतला narrow नहीं होता. Why? Because if it is thin, what will happen? The pressure which your shoulder will experience will be more. So if the straps are thicker and wider, what you are saying that the area has been increased, and when the area has been increased, pressure has been decreased, and you can walk on comfortably with your bag, keeping your books also in it. Okay. So till now we are studying about everything, nails, bags, straps, which you are seeing that is in the solid form. But do the liquid also exert pressure? Next topic we are studying that. Yes, now the question comes, is the pressure exerted by the liquids and the gases? Yes, the pressure is exerted by the liquids and the gases also. Right now we have studied about the solids, now we are going to study about the liquid and the gases. First the liquids, okay. So how does this liquid exert pressure? Okay, let us see some examples and do some activities. Okay, so take a glass tube, okay. एक glass tube लेना, okay, and at the end what you are going to do, you are covering it with a rubber, okay. That rubber is a flattened rubber. You can take basically the rubber of the balloon, okay, balloon ka rubber, you take it and just tie it over here, okay, at the end of this glass tube, okay. Now what you are going to do, you are going to add water to it. ठीक है, पानी डाला आपने. So you are adding water. What you are going to see then? That yes, this balloon, okay, it has got bulged, okay, when you have added water to it. Now, you are adding more water, okay. In this only, now what you are doing, you are adding more water to it. So what you are going to see over here, when more amount of water is added, okay. So now this bulging has increased, isn't it? This bulging has increased. When the height of this water is more, it means more water has been added to it. So here we can see that yes, this liquid, the water, okay, it depends upon the height also. If the height is more, bulging will be more. So pressure applied will be more if the height is more. Okay. Now, take another example. Okay. ये first हमने देखा है. In this we have seen that if height is less, pressure is less. If height is more, pressure is more. This we have seen by the bulging of this rubber which we have tied to the glass tube. Okay, now next, okay, we can see the pressure exerted by the liquid on the walls of the container. Okay, this liquid exerts pressure on the walls of the container. Okay, for that we can do an activity. Take a bottle. Okay, we have taken a bottle, and yes, here you are seeing not at the bottom but yes at the lower portion only. We have just cut that portion of the bottle, attached a small piece of tube which is tied with a balloon. Okay. Now what you are going to do is you are adding water to it. Okay? What you are adding? Water to it. When you add water to it, you will be seeing that this balloon now has bulged. Okay? So this is saying that yes, this liquid is exerting pressure on the wall of the container. As it is exerting pressure, what happened? This liquid is moving inside this balloon and it is being bulged. Now, suppose if I say that yes, this height of this liquid is this much, okay? Itna pani liya, it has bulged this much. Now I am giving a condition. If I have taken more water and I have increased its height till this much, what will happen? Here we will be seeing that yes, more pressure will be exerted and more amount of water will be going inside this balloon, and the balloon will be more bulged. Okay. So liquid exerts pressure on the walls of the container. Okay. Now one more activity let us see. Okay. Suppose we are taking a bottle. क्या लिया हमने? Bottle लिया. Okay. Now what we are going to do is at the lower portion, okay, we have just made cuts. Okay. So what we see, we are adding now water to it. Okay. Pani add here. Okay. We have added water. And we have made cuts at the equal height at the lower portion of the bottle. What do we see? The liquid or the water comes out. Okay. And yes, when we see the pressure, when we observe the pressure of this water which is coming out from the bottle is same. So when the height is same, the pressure exerted by the liquid is same on the walls of the container. Okay. So here I have said to you now some more examples. Okay. The pipes which are bringing water to our homes. Okay. If it gets damaged, what do we see? That water starts leaking. Because this liquid is exerting pressure on the wall. As there is a hole over there, the water goes out with the pressure. Okay, like that. You'll be seeing about the fountain. Fountain se bhi pani nikalta hai, isn't it? It also comes with the pressure. Okay, so this all things you have studied. Yes, the liquid exerts pressure. Okay, on the walls of the container, and yes, it also depends upon what? The height. Okay. Now let us study about the pressure exerted by the gases. So the gases also exerts pressure, okay, on the walls, like we have seen about the liquid exerts pressure on the walls. Okay. So you can see that yes, if you blow a balloon, okay, and if it has holes, are you able to blow the balloon properly? No, because the air gets leaked out from the walls of that balloon which is consisting of holes. Okay. Now, so this shows that yes, this gases also exerts pressure on the walls of whichever it is present. Here we have now seen about the balloon. Okay, it can be anything. If you fill air in containers also, you'll be seeing that yes, what happens? It gets totally the air. If you are trying to fill it, it will be moving out if it consists of holes or holes. Okay, and you can see very nicely also in case of this cold drink bottles. Okay, that yes, it exerts pressure. The gases exert pressure. When once the cold drink is being totally completed or used up, what happens? You keep those bottles. Okay, you'll be seeing after sometimes it gets deformed. Why does it gets deformed? Because these gases are exerting pressures on the walls of the bottles. ठीक है, कोई भी bottle आपने लिया है बेटा, okay, and any bottle of cold drink, okay, what happens after some time, you will be seeing what it gets, it is not in the proper form, then it gets deformed, isn't it? And why does it gets deformed? Because here this air is exerting pressure, okay, inside the bottle. Okay, so here we are seeing that yes, the air which is present here is totally deforming the bottle because it is exerting pressure on the walls of the bottle. So, let us study about this atmospheric pressure. Inside the air is present, outside also air is present. That is what? The air which is present in the atmosphere. So, air which is present in the atmosphere will create what? Atmospheric pressure. Okay, so this air, okay, where it is found on the surface of the earth, okay, totally enveloping the earth, and that is known as what? Atmosphere. And the pressure which is created by this air which is forms the atmosphere is known as atmospheric pressure. Okay, so if we are taking a cylinder, okay, and what is present inside it? The air. Okay, so this is equal to what? The air which is present inside the cylinder. Okay, here this will apply the atmospheric pressure. Okay, this and here you are seeing that yes, it is inside this. Here one more thing is acting, that is the gravitational force. So here the atmospheric pressure is equal to the what? The gravitational force. Okay, now taking one more example of this atmospheric pressure. Okay, take a rubber sucker. Okay, so it sucks air basically. Okay, so try to stick it on the floor. What you are doing? You are removing all the air which is inside it. So now what is happening? The atmospheric pressure is acting on it, and just try to remove that rubber sucker. Okay, you will not be able to, because here this pressure which is applied by the air is too high. Okay, now suppose a person is carrying a cylinder consisting of the air. So here atmospheric pressure is acting. Okay, so let us write the dimensions: 15 centimeter into 15 centimeter. Okay, so how much pressure it will exert, okay, and how much, I'll say, the force it is being exerting, it is 2250 Newton, or you can say 225 kg. Okay, so in this, if it is applying this much amount of force, then why the person head is not being crushed? Actually, here the gravitational force which is acting in his body is also this much. And as the result, the total is being cancelled and the person can carry that cylinder very easily, consisting of that object or the air. Okay, getting? Now, so this we have seen that yes, pressure is exerted by the solids as well as the liquids as well as the gases. Okay, in the solids, we have seen the perpendicular to the pressure where it is computed. Okay, that is the thrust. In the liquids and the gases, you have seen that yes, it exerts pressure on the wall, and yes, also you have studied about the atmospheric pressure. So this is all in this chapter, force and pressure. Hope you might have understood it. Good day. Take care.